All right, this is 1.3 derivatives practice. So we're just going to do some practice finding the slope of the tangent line at a point where its value point of time. Okay, anyway, let's go ahead and do the first example. So with our 4 examples that I have lined up for you guys today, make sure to pause the video and try it on your own. Okay, feel free to refer back to the previous videos for certain stuff and derivative notation and limit definition. Okay, pause the video. Feel free to get your resources out if you need them. Unpause if you're ready to go over everything. So please try it. See what you can do. All right, so this again derivative notation. It's a bit new. So d squared y by dx squared. Okay, we went over this. It's just it's just doing that limit twice. Doing that limit with the delta x. Doing that limit definition. Okay, I'm gonna call it the limit with the delta x. You should hopefully know what I'm talking about. That's called the limit definition. So just doing the limit definition. Taking the limit definition, remember, is the derivative. So just doing the derivative twice. Okay, so now you're like, wait, how do I do limit definition? I have a y here. Okay, really simple fix to that. Again, algebra 1. Let's just let y equal f of x. Okay, there we go. So now f of x equals 9x cubed. Okay, great. So now let's go ahead and find the derivative once. So we want to find dy dx first. So dy dx, in this case, right, we just do the derivative once, right? So that's going to be limit as delta x approaches 0. Okay, I'm just going to assume you guys know how to do this. So 9 times x plus delta x cubed minus 9x cubed all over delta x. And so then this will be limit as delta x approaches 0 of 9. And I'm just going to use, like, again, I know what this equals to, right? Like a plus b the whole cube. Feel free to actually FOIL it out, but I'm just going to use this x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. Okay, I think that's it. And then minus 9x cubed all over delta x here. So now I'm just going to distribute 9x cubed plus, and then this should be 27x squared delta x plus 27x delta x squared plus 9 delta x cubed minus 9x cubed over delta x. So again, a lot of algebra here, but just make sure you know what you're doing. And then here our 9x cubes will cancel. And then we'll get limit as delta x approaches 0 of 27x squared delta x plus 27x delta x squared plus 9 delta x cubed all over delta x. So now, again, typical process, just split these into separate fractions. So we get limit delta x approaches 0 of 27x squared, and then the delta x will cancel out here, and then and then plus 27x times delta x plus 9 delta x squared. Again, splitting these into two fractions and canceling out the delta x occurrences where they exist, and then reducing exponents. Okay, laws of exponents, stuff like that. So just algebra. Hopefully, you know I simplified how I got from this to this. Okay, just algebra. And so now we can do direct substitution here. So delta x 0, so this becomes 0, this becomes 0, and then we just get 27x squared. Okay, so this is not our final answer. This is dy dx. Okay, so dy dx is 27x squared. So we want to find d squared y by dx squared. So d squared y by dx squared Okay, I'm gonna let, okay, this f of x is different from this f of x. I'm gonna call just this f of x. Okay, this is like my scratch work. I'm gonna just set this again, this new function. I'm gonna call it g of x in this case. Okay, just again, just changing stuff up. I'm gonna just say g of x is 27x squared. Again, function notation still, so we can just do limit as delta x approaches 0 of g of x plus delta x, which is just 2 times 27 times x plus delta x squared minus 27x squared all over delta x. So then this will be limit as delta x approaches 0 of 27 times x squared plus 2x delta x plus delta x squared minus 27x squared over delta x. That's the limit as delta x approaches 0 of 27x squared plus 54x delta x plus 27 delta x squared minus 27x squared all over delta x. Let me rewrite that. All over delta x. These cancel out. And then we're left with limit delta x approaches 0 of, again, splitting these into fractions, so 54x plus 27 delta x. This goes to 0, it's directly substituting 0 in for delta x, and so we get 54x. So this is our final answer. D squared y, or dx squared, is 54x. Okay, so again, solve the question. D squared y by dx squared. 54x. That's our answer. Okay, let's do problem number 2. Okay, if f of x equals x, find f triple prime of x. Pause the video. Maybe doesn't require as much work as you think it does. Okay, unpause when you're ready to check. Okay, hopefully try to do this. Let's just start regular process here. Okay, limit delta x approaches 0. Okay, and we're plugging in x plus delta x in for x. So this should be x plus delta x, then minus our f of x, which is our x, all over delta x. Okay, these two cancel. We get limit as delta x approaches 0. Delta x over delta x. That's just going to be limit as delta x approaches 0 of 1, which is just 1. Hopefully this makes sense because the slope of x of y equals x, or f of x equals x is 1. This is 1x, so mx or m is 1. So this should make sense why we got 1. But this is not our answer. Okay, this is f prime of x. Okay, so what we found is f prime of x. So f prime of x is 1. So we try to do limit definition again here. F of x plus delta x is just going to be 1. Okay, we plug in any x value here, output's going to be 1. So it's just 1 minus 1 over delta x. Limit as delta x approaches 0. So then we get 0. Limit as delta x approaches 0 of 0, which is 0. And if we do this again with 0, we're going to get 0. So what are you kind of noticing here? Okay, what are you kind of noticing here? There's kind of a pattern here, which is going to lead us to a shortcut rule, kind of. Again, we may formally, I'll show the formal proof, but this is kind of leading us to a shortcut. You should hopefully be seeing a pattern here, right? We went from degree 1 to degree 0, and then we're just staying at 0, 0, 0, 0, 0. Okay, so f double prime is 0. And hopefully you realize that if we try to repeat this process again, right, do the limit definition of this guy again, x plus delta x of this guy is going to be 0. Then f of x is 0. Then that over delta x is 0. So that's going to still be 0. So hopefully you realize that this would just be 0. Okay, so f triple prime of x is just going to be 0. Okay, hopefully that makes sense. Okay, so now we're going to do another example. So make sure you try this. Okay, hopefully you realized from the same pattern as before. The same exact pattern. We saw that it went from degree 1 to degree 0, and then it just went to 0. Okay, if you do this, hopefully you realize that you will get, and now I'm not going to do the limit definition here. Hopefully this kind of makes sense. This will go to an x to the 11th. Then this will go to an x to the 10th. Then this will go to an x to the 9th. Then this will go to an x to the 8th, dot, 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 x to the 0. And then this will, of course, be 12 iterations until we get to x to 0. Okay, so then if we do it again, okay, we'll just have to get 0. Okay, because again, if we see if we have x is 0, which is 1, if we have f, whatever, f of 12 will be something, some number here, okay, times 1. If we just do number, okay, we'll just get number minus number over delta x, limit as delta x approaches 0, is just going to be 0, because this will be 0, 0 over delta x is 0, and then limit is delta x for 0, 0, 0. So again, it's just recognizing patterns here. Your answer will literally just be 0. Okay, so f 13th derivative, okay, is just going to be 0. Okay, so really, all you got to look for here is if this degree is 12 and you're asked for the 13th derivative, it's going to be 0. Okay, no question to ask. Okay, you should hopefully see that you're reducing by degree each time you take the derivative. Okay, and that's going to lead us to our shortcut rule. Okay, so going from, again, there will be some constant here. Again, I'm just saying number times 1 because this is obviously with the 3, and then, you know, that, again, it's leading to a shortcut rule, but it'll be something times an x of, something times an x to 11. Something times an x to the 10th, something times an x to the 9th, something times an x to the 8th, and then something times an x to the 0, which is the same as that something times 2 times 1. Okay, and that something times 1 will be the 12th derivative. Again, you can really actually do the limit definition 12 times, and you'll see that you will get a constant. You won't get any x's in your answer anymore. And then if you want to repeat this process for a constant with the limit definition, you'll see that you will just hit 0, like I showed you in the last example. Okay, so yeah, answer is 0 here. Okay, now this is, again, very straightforward, literally exactly like our first problem. Okay, so I'm going to leave this to you guys as kind of like a exit here. Okay, your answer should be dy dx equals 3x squared. Okay, so again, this is kind of like your exit ticket. Really, it's even easier than the first example we did. Okay, so hopefully this all makes sense.